power is now down out of this same question can be written like this. Okay, so now the 5 has come down. So that's the same question. 3 to the power of 5. The one I always go to, and you saw me do it a second ago, is if you... These two are the same statement, just written two different ways. Alex. You ready, Alex? Yeah, thank you. So we got this statement you can always work off. Yes, so the exponent comes out and becomes the equals part. So in a log, we have, if we have this as my original, if we want to rewrite that, I want the exponent on its own, exposed. The 2 is still the base, but it's written down here. And what was previously the answer comes in here as part of the, it's like 2 to the power of what gives 8. So that 2 to the power of something gives 8. That would you could translate that as. That's what a log means. Okay, so this means 3 to the power of 5 gives x. We have the answer this time. There's no something. Okay? Okay, so then if I have something like log 216 equals something, I can rewrite that. If you want to put a box here or an equal sign, 2 to the power of something is equal to 16. Sometimes you use x's, obviously, but 2 to the power, so 4. The answer to this is 4. All right, what about if we get a little bit trickier, like if we've log, what's that, 5 and 0.2 without a calculator? How would I do this? Okay, yes. So I'd convert this to a fraction would help. So this is an important thing. What's when we get the same thing here, 5, 5?
1.
Yes, 1, yeah. Okay, so what's the answer to this? Negative 1.
Wait, I don't get it. Because it's 0.2 log 5. Log 5 is 1, right? So no. 1 to the power of that's not the question.
Oh yeah, no, yes, that's not the question. Okay, anytime you see log x, that's 1. But we're not seeing that at the moment. We're seeing with a minus 1 here. So what is that?
Oh, sorry. I thought
There's a minus 1. So we had log 5 to the 1/5. So we didn't have log 5 here. Okay, let's move along. Log 10 to the cube root of, what's that, 100 or 1,000? 100. All right, so... Is that 5? Oh, yes. So that's log 10. 10 to the power of what? 2/5, I think. Where'd I get 2/5 from?
because it's root 5.
100's 10 squared, and root 5 is the power of 1/5.
Why can't you simplify? Wait, this is going to sound.
Okay, let's just go with the box here and let's see if we figure it out. This says 10 to the box is equal to 10 to the 2/5. So 2/5 must be what? Same as this one was minus 1.
For the cube of 100, why can't it not be cube?
It's not cubed. Fifth root of 100.
Fifth root of 100.
Yeah. Now I could.
Why can't you write that as 6th root of 10? Oh no, that's not the same thing. Sorry.
Okay. Yeah. No. You're going the wrong way. Yeah. You're adding 1 to the root instead of taking 1 away, or dividing 1. The last one then. What's that? Log 2 to the. Log 2 to the root 2? Or is it 1 over root 2? 1 over root 2. Okay. If you don't like this in log form, let's write it in exponential form. That means 2 to the power of something is equal to 1 over root 2. And you were just doing these the other day. So you could change this to 2 to the power of a half and move that up and becomes 2 to the power of minus a half. So this box is minus a half. Yes? Okay, not too bad. They're just reverse exponential ones, so you can change. There's a couple of rules to logs that maybe you know, maybe you don't know. I'm not sure. It depends how much detail your previous teacher went into with logs. Yeah, so if it's log 2, 5 plus log 2, 8, what does that equal? First rule of logs, the addition rule of logs. Log 240. I suppose the real question is why?
Yeah, I don't know. 5 times 8.
Oh, isn't log plus, if it's log plus log, it's just 5 times.
Oh, because they're.
Because you're adding the what you multiply.
No, square it. No,
Yeah.
That's yeah.
That's not fun.
You're adding what you square it by.
Yeah, kind of. Well, you know when we do exponents and you multiply exponents, you end up, oh, I add the powers. Well, this is the reverse. These are the powers. So you end up multiplying the answer. So it's the opposite to this.
That's why it's easy.
Exponents are the opposite to logs.
I should have seen that.
Okay, and then if we have the minus, you divide, yeah. Log 7, 8 divided by 2, which is log 7, 4.
What is this? What is this greater than 0 thing?
So what's the power?
What is this greater for and greater than negative?
Yeah, it won't work. It's not going to work. Why won't it work for negatives? Why can't we get a negative m or n?
Because it's squared. Or
Well, let's look at that. That's an interesting point. What's log 2 to the negative 5? What's that answer?
Wait, you can't do that.
something equals
You can't get something.
Why can't I get something?
Because you can't square something and get it bigger.
Yeah, but it's always squared.
It's 2, that rewritten is 2 to the power of something equals negative 5. And we've just been looking at exponential functions. What do we notice about 2 to the power of something? It looked like that. When's it going to be negative 5? Never. Okay, so that's why this number must be positive.
But n can be negative, right? Or can it not? I mean, so when it's behind.
When it's behind?
On the last
At the base? This number?
No, for the last line, when it's behind the log, n log a, e.
Yeah, that's okay. Yeah. Okay, and the last one then is this statement. So if I've log 2 to the power 2, 4, that's the same as log 2, 4 squared. This 2, or this number in front, can multiply up here. Multiply up here. How does that work? Why does that make sense? Yeah, that states then that log that states that that's the same. Does that make sense?
Yeah.
I suppose we could work it out. Log 2, 4, is it the same as log 2, 16?
Log 2, 4 is 2.
Yes.
And log 2, 16